Hello guys, we'll just continue doing revision for angles, lines and polygons, and we just keep on track, and now we go to a bit more complicated questions. We start from 15. Find unknowns. 1, 2, 3, 4. That's four-sided shape, so we just need to use the formula about the sum of all internal angles. That's the sum for internal angles. Who don't remember how it works and why is it so, just watch my proof about polygons. Why is that so? And here we just apply a ready to use formula. All right, so let's see. We just sum up all the angles. X plus 2x plus 120 and 180 together, it's 200 degrees. So finally it should be equal to, because it's four-sided shape, so it's definitely 4, n equals 4. 4 minus 2, it's 2. 2 times 180 is 360. So, or you can remember for every quadrilateral, you can figure out that the total sum of all internal angles is 360. All right, let's simplify. 3x equals to 160, from where each x simply is the third part out of 160. So let's divide it quick. 160 over 3. I'll get around 53 and 3 occurring. Okay, that's the answer. That stays for each x. Let's move next. So we have also need to find all unknowns. Let's just count how many sides. 1, 2, 3, 4, 5, 6, 7. All right, so it's heptagon, n equals 7. And we use again the formula n minus 2 times 180. And then we add all of the angles. So let's do it on the right side. So x, 2x, and x, it's 4x here. Then 7 over 4 x, then again 2x, and finally 5 over 2x. All right, so we plug n equals 7, we subtract, so we have 5 times 180, and on the right side there will be all x's. So if you want, you can factorize x or just simply add them. So I would use factorizing, and then I need to add 4 into it. It's going to be 6. And then I just add 7 over 4 and 5 over 2. I need to make denominators to be the same. So it's going to be 7 over 4. And I multiply by 2 the top and the bottom part. So I'll get 10 over 4. That makes me easier to add them. So 5 times 180 is going to be 900. So on the right side we'll have x. And here we get 17 over 4, and along with 6 we'll get 70 here, and 4 times 6 is 24. So we'll get something like this. All right, I can rewrite as 900 equals to 24 and 17. So 34 and 7, it's 41 over 4 and times x. So I put x in the top part according to the rule of multiplication. So what I'm going to have here, so I can use like fractional equation and simply to resolve it. So 4 times 900 and over 41. All right, so 41 simply goes down, so this 4 goes up, crisscross multiplication rule. So for someone who don't know this rule, how to resolve fractional equations, just try to watch my video dedicated to it. All right, so you can easily find that. It's in topic of equations. So here we have, that's what equals to x. And now let's multiply. So we have times 4 and over 41. So x is about 87.80. So depending on the questions, so I mean, if the question details you that you need to round up to 2 decimal place, so just round to like 3 significant figures. Also you can round. For example, I can show you to 3 significant figures. You take in the 3 digits starting from the first one, and because the last you do the cut, right? After the third digit you put the cut line, and so because it's 0, so you just simply cancel and erase that. This is the answer to 3 significant figures. All right, that's sort of extra. Okay, 17. Find the size of each interior angle for each of the following regular shapes. Alright, so we have pentagon, so 5 sides, n minus 2 multiplied by 180, and because we have on the right side sum of all interior angles and the shape is regular, instead of sum we can simply say that if one interior angle is I, stays for interior, so we multiply by number of angles. For n-sided shape we have n equal angles. So in order to find I itself, we just simply divide by n. So we cancel it here and n appears in the bottom part. So simply we can use this formula for I. That's the formula, and you can apply it to pentagon. So pentagon, so the first one, pentagon, 5-sided shape, so n equals 5 for pentagon, and we just simply calculate 5 minus 2 is 3 over 2 times 180. Alright, that stays for I. And you can calculate, so canceling, and it's 270 occurs. Alright, so hexagon. Hexa means 6. Alright, n equals 6. And we just put it in the equation. So 4 over 6 times 180. From where you can cancel 6 and 180, that's 30 on the top. And we just multiply it to 120, stays for hexagon. Alright, octagon. Octopus, remember. Octagon. N equals 8. 8 legs here. Alright, so we put n equals 8. Put in the formula, so we have 6 over, and the bottom is 8, so multiply 180. Okay, what we can do, we just cancel 6 and 8 by 2, 3 over 4, then 4 by 180 occurs to be 45, right? By 2 it's 19, one more time by 2 is 45, and just 45 times 3, that's going to be a result. We'll get I equals 135. And the last one, decagon. Alright, so for decagon, n equals 10. So do the same. 10 minus 2 is 8, and over 10 times 180. So simply can erase that 0 and 10 finally. I'll get 8 times 18, so 144. So I equals for decagon, I equals 144. Alright, let's move to the next one. The sum of angles of a polygon is 3,600. How many angles has this polygon? Alright, so we just need to know that n minus 2 times 180 is going to be 3,060. So how many angles? So basically we need to find n from here, and that's a very typical task. Alright, so we cancel, and then 360 by 18, we just simply divide 360 by 18. We'll get 20 on the right side, so n minus 2 is 20, or simply n equals 22. So 22 angles, 22 sides. Alright, 19. I found a polygon which has the sum of all interior angles to be equal to 2,000. Alright, so we have in the formula stated above that this amount is equal to 2,000. Alright, sum of all interior angles. Is it realistic polygon? Alright, to judge about realism, does this polygon exist? Basically, you need to find out n, and n should be integer, right? because realistic polygon should have an integer number of sides, so integer. So that's why we need to find out n. All right, let's do that. Simply divide by 180. So we take 2000 and divide by 180. So we'll get fractional number 11 point and 11th, just repeating digit. So obviously if we even transfer 2, we'll get 13 and 1 still be repeating. So it is not integer. So this polygon doesn't exist, all right? So 20, maybe more complicated task. You have a hexagon slice with 3 lines. Okay, so those 3 lines here. Okay, find all unknown angles. Okay, that's the first question, so that's why we first try to answer that. Find unknown angles. They're all different. It looks like they're really a lot. Okay, so hexagon, a 6-sided shape, so we first state that n equals 6, and probably, first of all, in order to find x and take into account, I guess, actually you're not stated what sort of hexagon it is. So in this case, we need to assume that it's drawn to scale, so all sides the same. So it should be regular actually. So that should be regular. Only in this case we might find that. Otherwise it's impossible. So we given the regular hexagon, so that's why all sides equal. And so let's have a look at triangles. Let's mark them: A, B, C, D, E, F. All right, so let's consider triangles ABC as well as triangle AFE. They are isosceles, so put the word iso, a shortcut. All right, so if it's isosceles because of 2 sides the same, right, we are agreed to have x angle here because angles at the base should be the same, and here we can state that this angle is m degrees. All right, so, and what if, assume that we know interior angle, so we put I for that, that's interior angle. Can we calculate that? And if we know that, we can figure out x values, all right? So that's why we put the formula n minus 2 times 180, and instead of n, that's the sum of all interiors angle, the sum of all interiors angle. So or simply, as according to the previous, I is simply divided by n, that's how we can figure out I itself. Okay, instead of n we put 6, and we have 6 minus 2 times 180 over 6. Okay, so we have for I, for each interior angle, 4 over 6 times 180, or in other words, so we can cancel that, 30 and 120. Or you can just remember like standard shapes like hexagon, pentagon, quadrilaterals, and up to decagon if you like, and you can easily know the angle. But if you want to prove, just use the formula and you'll get the answer without any memorizing. So I prefer this way. So let's see next. Okay, we have I equals 120, so instead of I we just simply put 120 here, and also 120 will be there. So looks like all x's and all m's the same. So first of all, we can state that x equals m. Obviously triangles are congruent because they're the same. So in terms of similarity, they have also not only the angles the same, but all the sides. So in angle between the sides that are the same is also the same, so 120. So triangles congruent. All right, so we can figure out if x equals m, and just simply we can, for example, for triangle ABC, we just simply put equation for the sum of all interior angles plus 120, that would equals to 180, right? And from where we can have 2x equals 180 minus 120 is 60, from where x is half, so 30 degrees. and it's also m. So we figure out that instead of m, and also x and x, we have 30 degrees. Okay, so x equals 30 here, and m also equals 30. All right, let's have a look at the triangle ACD. Okay, so triangles ACD and the second triangle ADE. ADE. So I'm talking about this one and this one. All right, so it seems to me they're also the same, but however, let's have a look why they're the same. We proved that this AC equals to AE, so we know that AC equals to AE. We also know that AD is common, right? AD is a common segment. Two triangles basically share the common sides. All right, so we also need to prove that two angles should be the same, right? Oh no, we simply have the regular polygon. That's why CD is also equals to DE, and that's why all three sides in one triangle are equal to the corresponding side in another triangle, so they're also congruent. So that's why angle Y is actually the same as angle Z. All right, so we can state that if we add them up, we'll get 2y simply. And let's have a look at the angle, interior angle BAF. So we consider angle BAF as interior. Let's see what it consists of. It consists of 30, another 30, and 2y simply, because y is the same as z. So that's why we can add to 2y simply 30 twice. So that means 60. And hence we'll get the interior angle, which is 120, as we recently found. From where we can figure out that 2y is simply 120 minus 60 is 60, and that's why for 1y we can have, let's say, finally from here we can have that y is 120 minus 60, 60 and over 2, 60 over 2, which is also 30. Because z is also equal to y, we'll get all angles by 30 degrees. Okay, all angles by 30 degrees. Okay, so we found them. We answered that question. Find all unknown angles. Now, what can you say about type of triangles formed in this way? Okay, so type of triangles. ABC, we proved that ABC is the same as AFE, and also two other triangles are identical. Okay, but maybe they ask about the type. So first of all, we can say that A, B, and C an isosceles, right? So that's why AFE is also an isosceles. Okay, we have 30 degrees here. Okay, so probably they're definitely like those triangles, ABC, I just marked them. They are isosceles, so that's why the answer to that question, I just erase the space here. Oh, okay, I can write here. So the triangles ABC, which is equal to triangles AFE, they are isosceles, okay, with two equal sides. Now let's consider other triangles. Triangles ACD will be equal to triangle ADE, and they are also the same. But let's have a look at which type of triangles they are. Okay, we have 30 degrees for each one. So we have a known angle at the corner C or at the vertex C. But we know that this angle is 120 because it shares an equal parts. That should be 60 and that should be 60. Okay, we have 30 degrees, 60. If we add them up, we'll get 90 degrees. So that's why this angle actually is a right angle. So we can say that this angle will be right angle and this also is right angle. So what sort of triangles we have? They're right angled triangles, because angle ACD D is 90 degrees. We just proved that. So let's check. 30 plus half of the interior angle, which is 60, and plus the angle ACD should be equal to 180 degrees, the sum of all interior angles. All right, and indeed from here ACD is 90 degrees, so we proved that. So we consider both triangles and classify them as either isosceles or right angles. So 20 task is sort of hard, definitely high tier, high level, and I mark as a star. So hope you did in the same manner. If not, just one more time, try to consider each triangle, and you know that the key role here is how you cope with angles. So that's the main idea, and you always use the rule for polygon. That's the case. All right, so let's move to the 21. Okay, so we have a triangle and we need to calculate the size of angles A, B, and C. All right, so let's see, we have 30 degrees. So we need to find all the angles marked with letters. So let's consider at the first A and B. What do we know about them? So let's write several equations that are really helpful for us. A in addition with B should form 180 degrees, because you remember about angles which add together each other to 180 degrees. That means the total angle is open. So this angle is open angle. The measure is 180 degrees. All right. So that's why we move next. We also know that C and 40 should form the rest part of the angles in the triangle. So because we know that if we add 90 degrees with 30 degrees and with the rest part, which is C and 40 together, we'll have the sum of all interior angles in the triangle. So we consider triangle PRQ, and for that we have the sum of all interior angles is 180 degrees. All right, so let's simplify. 90, we transfer it here, 30 transfer it here, and 40 also transfer it here, so we stay with C. So 180 minus 90 is 90, minus 30 is 60, 60 minus 40 is 20 degrees. All right, so we've got the C is 20 degrees. All right, we put it here. Next one. We know in a smaller triangle, I put the letter L, and let's consider triangle LPQ. So what we know about the angles again, if we add A 90 degrees and 40 degrees, we'll get 180 again. So from here, A is simply the difference between 180 and this sum. So 180 minus 90 is 90, 90 minus 40 is 60 degrees. All right, so we know, that angle A is 60 degrees. So what about B? We just use the very first equation that we set up, maybe in advance, too early, but anyway, we have it already. So what stays for B? We just express B. B is 180 minus A. Because A is 60 degrees, we can figure out that B is simply 120 degrees, and it looks right and correct because this angle is an obtuse angle, while A, for example, as well as C, they are acute angles. So everything done. All right, so guys, hope you enjoy. I paused here, and I think that we've completed a lot from this revision. And finally, I think we'll do the last revision dedicated to lines, polygons, and angles. So hope you enjoy, hope you had a good practice with me. So don't worry if you didn't succeed like on A star. I mean, during practice, just try to go back to the explanation. I'm sure that you'll find out more than probably right now. So obviously, if you watch several times explanation, you'll get an idea. So don't think about the time. So all my videos dedicated to cover the whole program for GCSE and IGCSE. So for this reason, if you just every day you watch one video, you'll definitely succeed in your exams. So I structure it and I construct my channel in this manner so that you can get prepared for GCSE and IGCSE at a very high level. So that's why my goal and the intention of my channel and my videos is basically to encourage you to watch, practice, and get the high score. So I hope you enjoyed. Don't forget to subscribe. Don't forget to share this video to interested persons and to anyone who want to get a high score, and you'll get it, definitely, trust me. See you guys later.